Let us look at how to solve another linear programming problem using graphical method. A man operates a push cart. He sells burgers and lime juice. His cart can support 210 pounds. So the weight of burgers and lime juice combined should be less than 210 pounds for the push cart. A burger weighs 2 ounces and lime juice weighs 8 ounces. He knows from experience that he must have at least 60 lime juices and at least 80 burgers. So he knows what is the demand, how much he will be able to sell. So at least 60 lime juices and at least 80 burgers he'll be able to sell. He also knows that for every 2 burgers he sells, he needs at least 1 lime juice. Given that he makes 8 cents profit on a burger and 4 cents profit on a lime juice, find how many burgers and lime juices he must have in order to maximize profits. So let us understand this problem in detail. So suppose this is a push cart that the man is using. And on this push cart he is selling burgers and lime juice. So suppose he has, these are burgers and this is lime juice. Now it has been given that the cart can support a maximum weight of 210 pounds. So the weight of burgers and lime juice combined should be less than or equal to 210 pounds. Now each burger weighs 2 ounces. So weight is equal to 2 ounces per piece. And each lime juice weighs 8 ounces. So for lime juice, weight is equal to 8 ounces, again per bottle or per pack or whatever, so per piece. Now the total weight has been given in terms of pounds, while the weight of burger and lime juice has been given in terms of ounces. So at some point in time when we solve this, we'll have to convert either pounds into ounces or ounces into pounds. But the general conversion is that 1 pound is equal to 16 ounces. So each burger weighs 2 ounces. In terms of pounds, it will weigh 2 by 16 or 1 by 8 pounds. Similarly, each lime juice weighs 8 ounces. So in terms of pounds, it will weigh 8 by 16 or 1 by 2 pounds. Now it has been given that he knows the demand for burgers and lime juice. So he knows from experience that he must have at least 60 lime juices and at least 80 burgers. So the quantity of lime juice should be at least 60. So should be greater than or equal to 60. And the quantity of burgers should be greater than or equal to 80. He also knows that for every 2 burgers he sells, he needs at least 1 lime juice. So basically he needs twice the quantity of burgers as compared to lime juice. So here we have shown two lime juices, so he will have to carry 4 burgers. Now we have also been given that he makes 8 cents profit on a burger and 4 cents profit on a lime juice. So profit is equal to 8 cents per piece, and for lime juice profit is equal to 4 cents per piece. Now with this information given, we want to find out how many burgers and lime juices he must have in order to maximize the profit. Now in order to solve this problem using linear programming model, let us first note down the data provided to us. So we have burgers and lime juice. First we have been given the weight, which is 2 ounces per piece for burger, and it is 8 ounces per piece for lime juice. Next is the quantity. So for burger it should be greater than or equal to 80, and for lime juice it should be greater than or equal to 60. Next is the profit. So for burgers, profit is 8 cents per piece, and for lime juice the profit is 4 cents per piece. In addition to this, we have also been given the maximum weight for the cart. So weight should be less than or equal to 210 pounds. So first step would be to determine the decision variables. So here we need to determine the quantity of burger and lime juice in order to maximize the profit. So let X be the quantity of burgers and let Y be the quantity of lime juice. Here X and Y are the decision variables. Next step would be to determine the objective function. Here the objective is to maximize the profit. So let's say P is the profit. Now the overall profit would be the addition of profit from burger and lime juice. Now for burgers, we have been given that the profit is 8 cents per piece, and we just now assumed a quantity of X for the burgers. So for one burger the profit is 8 cents. So for X burgers the profit will be how much? Let's say this is X1. So if we cross multiply, X1 multiplied by 1 is equal to 8 multiplied by X. So X1 multiplied by 1 is X1 is equal to 8X. So the profit for X number of burgers would be 8 times x. So P is equal to 8x plus, now the profit for lime juice for each piece is 4 cents, and we have assumed a quantity of y for lime juice. So with the same logic that we did the burgers, the profit for y quantity of lime juice would be 4 times y, and here we have to maximize profit, so we have to maximize p. So our objective function becomes p is equal to 8x plus 4y. Now this profit is in terms of cents, and say $1 is equal to 100 cents. So let's convert this objective function in terms of dollars. So if we divide each of these numbers by 100, we'll get in terms of dollars. So P is equal to 8 divided by 100 times x plus 4 divided by 100 times y, or P is equal to 0.08 x plus 0.04 y. So this is our objective function in terms of dollars. The next step would be to determine the constraints. So the first constraint that has been given to us is that the cart can support a maximum weight of 210 pounds. Now it has been given that each burger weighs 2 ounces while each lime juice weighs 8 ounces. Now let us convert these in terms of pounds. So 1 pound is equal to 16 ounces. So x pounds, or say x1 pounds, is equal to 2 ounces. Now if we cross multiply, 2 multiplied by 1 is equal to 16 multiplied by x1. x1 is equal to 2 divided by 16 is equal to 1 by 8. So this is 1 by 8 pounds, which is equal to 2 ounces. Same way for lime juice, 1 pound is equal to 16 ounces, and say again x2 pounds is equal to 8 ounces. So cross multiplication, 8 multiplied by 1 is 8 is equal to 16 times x2, or x2 is equal to 8 by 16 is equal to 1 by 2. So lime juice is 1 by 2 pounds or 8 ounces. So the weight of each burger is 1 by 8 pound. So the weight of x number of burgers would be 1 by 8 multiplied by x. Similarly, the weight of each lime juice is 1 by 2 pounds. So the weight of y number of lime juices would be 1 by 2 multiplied by y. And the addition of the weight of burgers and lime juices should be less than or equal to 210 pounds. So this becomes our first constraint. Let's note this down. So 1 by 8 x plus 1 by 2 y is less than or equal to 210. The second constraint that has been given to us is that the quantity of burgers should at least be 80, or in other terms it should be greater than or equal to 80. So x, which is the quantity of burgers, should be greater than or equal to 80. So that becomes our second constraint. x should be greater than or equal to 80. This is our first, say this is our second constraint. Now the third constraint given to us is the quantity of lime juice should at least be 60, or in other terms it should be greater than or equal to 60. Now we already considered y as the quantity of lime juice, so y should be greater than or equal to 60. So this becomes our third constraint. Y should be greater than or equal to 60. Now the fourth constraint given to us is that for every 2 burgers he sells, he needs at least 1 lime juice. So suppose he is selling 2 burgers, and for that he needs at least 1 lime juice. Now the overall quantity of burgers has been assumed as X, and the overall quantity for lime juice has been assumed as Y. So if we consider the least amount of Y required for X, half of X will be equal to Y. So the constraint says that for every 2 burgers he sells, he needs at least 1 lime juice. So suppose the last or the least case is that he has 1 lime juice and 2 burgers. So if we have half of the quantity of burgers, that will be equal to the quantity of lime juice. Now the statement which says he needs at least 1 lime juice, so if he has 2 burgers, he can have 2 lime juices or 3 lime juices or any other number, but at least he needs to have 1. So y can be greater than or equal to x by 2. So that becomes our fourth constraint, that is x by 2 is less than or equal to y, or in other terms x is less than or equal to 2y, or 2y minus x is greater than or equal to 0. So this becomes our fourth constraint, 2y minus x is greater than or equal to 0. So these are the constraints that we need to plot on the graph in order to maximize the profit. So let us first simplify this equation here. This equation has 1 divided by 8x plus 1 divided by 2y is less than or equal to 210. So let us simplify it for the ease of plotting. So 1 by 8x plus 1 by 2y is less than or equal to 210. So let's take the LCM here, which will be 8. So x plus 8 divided by 2 is 4. So 4y is less than or equal to 210, or x plus 4y is less than or equal to 210 multiplied by 8, or x plus 4y is less than or equal to 1680. So this also is our first constraint. So let us now plot these constraints to see the feasible solution region and then work our way towards finding the optimal solution. To plot the graph for the 4 constraints, let us assume that the horizontal axis, which is the x-axis, represents the quantity of burgers, and the vertical axis, which is the y-axis, represents the quantity of lime juice. Now since there is a non-negativity restriction on the decision variables for linear programming model. We have considered the first quadrant of the graph where the values of x and y is positive. Now in order to plot these constraints, we'll drop the inequality sign. So our first constraint, which is x plus 4y is less than or equal to 1680. Instead of that, we'll consider plotting x plus 4y is equal to 1680. Same way, x is equal to 80, y is equal to 60, and 2y minus x is equal to 0. These equations would then represent a straight line. So all the points on the line would represent the equal function, that is, say for example, x plus 4y is equal to 1680, while all the points below that line would represent the less than function. So those will represent x plus 4y is less than 1680. Now in order to plot these lines, we have to first find 2 points which would fall on this line, and then using these 2 points, then we can draw the lines. Now the easiest points would be the x and the y intercept. So if we put x and y as 0 turn by turn for each of these equations, we will get the value of x and y intercept, and then we can plot these lines. So let us start doing that with the first equation, which is x plus 4y is less than or equal to 1680. So the first equation is x plus 4y is equal to 1680. So considering x is equal to 0, our equation becomes 4y is equal to 1680, or y is equal to 1680 divided by 4. This is equal to 4 4s are 16, 4 2s are 8, and 0. So y is equal to 420. Same way, if we put y is equal to 0, we'll get x is equal to 1680. So the x-intercept is 1680, while the y-intercept is 420 for the first line. The second line is x is equal to 80. So this itself is the x-intercept, and of course y is 0 here. The third equation is y is equal to 60. So this is the y-intercept, and in this case x is equal to 0. The next equation is 2y minus x is equal to 0. So in this, if we put x is equal to 0, we get 2y equals to 0 or y equals to 0. If we put y equals to 0, we get x is equal to 0. So let us now plot these lines to find the feasible solution region. Now, once you get these coordinates or these intercepts, you know the maximum intercept at x is 1680 and on the y-axis is 420. So when you're plotting a graph based on these maximum values, then you can determine how to plot these. So in this case, we will plot it in terms of hundreds, both x-axis and the y-axis. So as you can see in the graph, I have taken the quantities in hundreds for both x-axis and y-axis, and I have ensured that we can plot the maximum intercepts on the x-axis as well as y-axis in the graph. Now the first line, which is x plus 4y is equal to 1680, has an x-intercept at 1680 and a y-intercept at 420. So since x-axis is in terms of hundreds, we need to plot this line so that it intersects the x-axis at 16.8 and the y-axis at 4.2. So let us draw this line. So this line represents x plus 4y is equal to 1680, and all the points below would represent x plus 4y is less than 1680. Now the next line is x is equal to 80. So this has an x-intercept at 80 and a y-intercept at 0. So it has a y-intercept at 0 means that it does not intersect y-axis. That means it is parallel to y-axis. And x-intercept of 80 in our graph, because we have taken quantity in hundreds for the ease of plotting, the x-intercept will be at 0.8. So let us draw this line. So this line represents x is equal to 80. The next line is y is equal to 60. This has a y-intercept at 60 and an x-intercept at 0. So since it has a x-intercept at 0, it is a line parallel to the x-axis, and y-intercept at 60 in our graph it will be at 0.6. So let's draw this line. So this line represents y is equal to 60. The fourth equation is 2y minus x is equal to 0. Now this line has an x and y intercept of 0. That means that it passes through the points x is equal to 0 and y is equal to 0. That is the origin. So this is a line which will only touch the origin. So let us draw this line. So this line here represents 2y minus x is equal to 0. So now that we have drawn all the four constraints, we need to identify the feasible solution region, which is the common area covered by all these four constraints. So the first line is x plus 4y is less than or equal to 1680. So this is the line. So the inequality sign, which is less than or equal to 1680, indicates that the feasible region for this constraint is in this direction, that is the downward direction. The second equation is x is greater than or equal to 80. So the value of x is going to increase, and that is the feasible solution for this equation. So x is greater than or equal to 80 indicates feasible solution in this direction for this constraint. Third is y is greater than or equal to 60. So this is the line, and y is greater than or equal to 60 means on the upward direction. So this is the direction. And fourth is the equation 2y minus x is greater than or equal to 0. Now for the fourth, which is 2y minus x is greater than or equal to 0, let us identify the feasible region for this constraint by identifying 2 points, one on each side of this line. So let's take the first point which is 2 and 4, which seems to be in this area above the line. So 2 and 4. So let's substitute 2 in place of y. So 2 multiplied by 2, which is 4, minus, and the x-axis we are taking is 4. So this is 4, and this is equal to 0. So it does satisfy this equation. 2y minus x is greater than or equal to 0. Let's now take another point, which is x is 12 and y is 1, which is on the other side of this line. So y is 1, so 2 multiplied by 1, which is 2, and x is 12, so 2 minus 12, this is equal to minus 10. So minus 10 is less than 0, and this inequality is 2y minus x is greater than or equal to 0. So this does not satisfy this condition. So definitely the direction of the feasible solution for this constraint is in the upward direction. So with these 4 lines, this area here, which is A, B, C, and D, this area is the feasible solution region. Note that here this becomes a little tricky. So from B to C, at this point where this line is intersecting with the line y is equal to 60, this forms the point C. And after that, this is the pink line, which is the boundary of this feasible solution region. And then at the intersection of this green and the pink line is the point D. So the feasible solution region is from B to C to D, and then up to A, and then coming down to B. So once we have identified the feasible solution region, we now need to find the value of x and y, which would maximize the profit. So there are 2 ways in which we can approach this. First is, we take the objective function line, which is p is equal to 0.08x plus 0.04y, and draw a series of objective function lines parallel to each other. On any particular line, the different combinations of x and y will yield the same profit p. Now as we move upwards away from the origin, the farthest line from the origin touching the feasible region will represent highest profit. So once we identify the point where this farthest line is touching the feasible solution region, then we can identify the coordinates of that point. The coordinates of that point, that is the value of x and y, will be the value of the quantity of burgers and the quantity of lime juice that the person should be carrying in the push cart. The second method says that the optimal solution lies on one of the edges of the feasible solution region. So it can be either A or B or C or D. So we can identify the coordinates of these 4 points, and then if we solve the objective function line for the value of p, then the coordinate which gives the maximum value of p will be our optimal solution. Now to identify the coordinates of these edges, if we solve the 2 equations of the lines on the intersection of which these points lie, then we can find the value of x and y for these points, and then we can fill these values in the objective function line to solve for p. So for example, point A lies on the intersection of x plus 4y equals to 1680 and x is equal to 80. Point B lies on the intersection of x plus 4y is equal to 1680 and 2y minus x is equal to 0. Point C lies on the intersection of 2y minus x is equal to 0 and y is equal to 60. Point D lies on the intersection of y is equal to 60 and x is equal to 80. So let's solve these equations to find the coordinates of the points A, B, C and D. So point A lies at the intersection of x is equal to 80 and x plus 4y is equal to 1680. So to solve these two equations, we already have a value of x is equal to 80. So let's put that value in this equation. So 80 plus 4y is equal to 1680. 4y is equal to, bringing 80 on this side, so 1680 minus 80 is equal to 1600. Y is equal to 1600 divided by 4. This is equal to 400. So the coordinates of point A are 80 and 400. Now point B lies at the intersection of x plus 4y is equal to 1680 and 2y minus x is equal to 0. So if we solve these two equations, x plus 4y is equal to 1680 and minus x plus 2y is equal to 0. So x minus x gets cancelled. 4 plus 2, 6y is equal to 1680 plus 0, so 1680. Y is equal to 1680 divided by 6, and this is equal to 6 2's are 12, so 2 and 12, so 16 minus 12 is 4, so 4 carry over. 6 8's are 48, so 8, and bringing this 0 down, so y is equal to 280. So we got y is equal to 280. Now let's put the value of y in any of these equations. Let's take this equation. This is much simpler. So 2 multiplied by 280 minus x is equal to 0, or x is equal to 2 multiplied by 280, or x is equal to 560. So the coordinates of point B are 560 and 280. Now point C lies on the intersection of 2y minus x is equal to 0 and y is equal to 60. So let's put y in this equation. So 2 multiplied by 60 minus x is equal to 0, or x is equal to 120. So the coordinates of point C are 120 and 60. Now point D lies on the intersection of x equals to 80 and y equals to 60. So these become the coordinates of the point D. So D has coordinates of 80 and 60. Now let's use these coordinates to solve the objective function equation for the value of p. So our objective function is P is equal to 0.08x plus 0.04y. So let's solve this for point A, which has coordinates of 80 and 400. So P is equal to 0.08 multiplied by 80 plus 0.04 multiplied by 400. This is equal to 6.4 plus 16. This is equal to 22.4. Now let's solve the objective function equation for the coordinates of point B, which are 560 and 280. So P is equal to 0.08 multiplied by 560 plus 0.04 multiplied by 280. This is equal to 44.8 plus 11.2. This is equal to 56. Now next let's solve the objective function equation for coordinates of point C, which is x is equal to 120 and y is equal to 60. So P is equal to 0.08 multiplied by 120 plus 0.04 multiplied by 60. So this is equal to 9.6 plus 2.4. This is equal to 12. And the last is point D, which is 80 and 60. So P is equal to 0.08 multiplied by 80 plus 0.04 multiplied by 60. This is equal to 6.4 plus 2.4, and this is equal to 8.8. So after solving the objective function equation for all the points on the edge of the feasible solution region, the maximum profit is derived at point B, which has x as 560 and y as 280. So the solution is to carry 560 burgers and 280 lime juice. This is the optimal solution.